Let me introduce my next problem, which is problem number 3 in this lecture. And the problem is telling that a rectangular rigid fixed block has a long horizontal edge. A solid homogeneous cylinder of radius capital R is placed horizontally at rest with its length parallel to this edge such that the axis of cylinder and the edge of block are in the same vertical plane. I shall introduce the figure very shortly. There is sufficient friction present at the edge so that a very small displacement causes the cylinder to roll off the edge without slipping. Determine the speed of center of mass of the cylinder before it leaves contact with the edge in terms of radius of the cylinder and free fall acceleration g. A lengthy question you'll understand with a figure, but I'll suggest you see the question very thoroughly. It might go out of our view in a short time. There is so much of writing to do and figures to draw. This is one of the most challenging problems we have done so far. So here they are telling about a rectangular rigid fixed block, and this is the horizontal edge shown in dashed line. I'll be using 3 different colors here so that there is no confusion regarding the outlines of the block and the cylinder in 2 different positions. So initially the cylinder was placed at the edge of the rectangular block so that you can see a portion of it is just sticking out of this edge, and the axis of the cylinder, this blue straight line, that is lying vertically above the edge of this rigid block, isn't it? They are telling here this axis of the cylinder and the edge, horizontal edge of the rigid block, they are lying in the same vertical plane initially, and it's an equilibrium. Now a very gentle push, very small displacement is given to the cylinder and it starts rolling about this edge of this rigid block, and so that in its new position that I am showing by this red outline, this is the same cylinder but in a new position because it just begins to roll about this horizontal edge of this block, and as a result you are understanding that its new position is this one, and the axis shown by the red arrow has come a little below the initial position of the axis of the cylinder. And they are telling determine the speed of center of mass of cylinder before it leaves contact with edge in terms of r and g. So first of all, what we'll do is that we'll understand initially, before the cylinder was given this small displacement, if I could take any point on its axis, this point is vertically above the point of contact. I'm just considering a vertical section of the cylinder, and I show that this point on the axis is lying vertically above the point of contact with this block. But that was initial condition. When it is just beginning to roll on this edge of this table or this block, now the axis, a point on the axis and the point of contact, they are not any further on a vertical line. So if you join this point of contact with the block and a point on the axis of this rolling cylinder, this radial line now is making an angle of theta with the vertical direction, that is the direction of initial line joining the point on the axis and the point of contact. This you understand. As it begins to roll, this line joining a point on axis and the point of contact with the block, that also keeps rotating, and I consider an intermediate situation where this value is theta. So this figure will not be very clear for us because I have to consider the motion here, not of any arbitrary point in the cylinder. We shall consider the equation of motion.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.